Hey guys, welcome to the session by Intellipaat. Today we are going to discuss about Pig, which was originally developed by Yahoo in the year 2006 for researchers to have an ad hoc way of creating and executing map-reduced jobs on large datasets. It was created to reduce the development time using its multi-query approach. So before moving on to the session, please subscribe to our channel so that you will never miss an update on our upcoming videos. If you want to get certified as a Big Data Hadoop architect, Intellipaat offers a course on this. Please go through the link provided in the description. Now let us take a quick glance at the agenda. We will be getting introduced to Pig by starting with the history and discuss what exactly is Pig and its components. And then we will learn about the power of the Pig by getting introduced to its features and advantages. Once you are clear with the power of the Pig, you will learn the user scenario and see the comparison between Pig and Hive. And also you will see some of the complex data types in Pig. And then we will start working with Pig and learn how to run Pig in local mode and map reduced mode. And also you will go through the schema in Pig. And we will get introduced to various operators in Pig like load operator, store operator, relational operator, and so on. After getting introduced to operators, you will be learning the word count program and grouping data. And then finally you will be performing weather data analysis.
So the question is like, what is Pig and is it something similar to Hive? I have heard a lot about Pig. So where it is used, where it is not used. The first thing I'm going to tell about Pig is that, so this might be a little bit confusing, but still, Pig and Hive were invented almost at the same time to solve the same problem, meaning both these tools were invented almost at the same time, and both these tools allow you to solve the same problem. Well, almost the same problem, I can say. In most of the cases where you can use Pig, Hive can also be used. There are some situations where you cannot, but mostly. So you may be asking, then why did you just invent one tool? Why did you invent two tools? If Pig and Hive are almost the same, then why do you have two tools? See, the answer is very simple. Remember the use case of Hive? So Facebook was dealing with massive amount of structured data, and they were running most of their queries and all on Oracle with hand-coded Python, and that was the stage set for the invention of Hive, right? So Facebook had to move to Hadoop and they had to query the data and they didn't know what to do. So they practically invented something called Hive. At the same time, Yahoo was facing the same problem, but in a different way. So you see, Yahoo is the company who practically kind of invented Hadoop. They did not invent Hadoop. They basically acquired the Nutch project actually, but the first stable release of Hadoop actually spun out of Yahoo, right? So when Yahoo had Hadoop, okay, the same problem was there. All right, I want to work with the data in Hadoop, but the only way is MapReduce. That means I have to force my employees to learn Java, then write MapReduce code. What should I do? But Yahoo thought it in a different way actually. What Yahoo thought was, right, all right, let's create a scripting tool. Let's create a scripting tool which is very easy to learn so that people will just install it, write their script, and just run it. And the scripting tool is going to convert the script into a series of MapReduce programs, and that is your Apache Pig. So even though Yahoo invented it, later they contributed that to Apache, and it became a top level project. And you will be surprised to know that somewhere around 2013 and 2014, I think around 70 to 80% of ad hoc jobs in the world of Hadoop were achieved only using Pig. Pig is so popular actually, one of the most popular tool. Well, not very recently, after the invention of Spark, in fact, Pig's popularity is not as we see today, but yes, still Pig is one of the best choice for all the programmers and analyst folks, right? So what exactly is Pig? We will see. So to give you the backdrop, this was invented by Yahoo at the same time when Hive was invented by Facebook. The only problem, these two companies did not talk to each other, right? So they didn't know that they were trying to solve the same problem and ended up inventing two tools. What is Pig? So it's basically a scripting language used for exploring large data sets. Now it is a new language, which means you will get some time to use to it. So the learning curve of Pig is higher than that of Hive. To put it in another way, if somebody has to learn Hive, it will be much easier since Hive follows SQL and most of us know SQL. You can just get a Hive CLI and start exploring right away. But when you start with Pig, Pig has its own language called Pig Latin. So Pig's language is called Pig Latin, and Pig Latin is a new language. So the syntax, how you use it, all are new. So you'll take some time to get familiar with Pig, but that's all fine. I'm gonna help you to figure out how to learn Pig and how to work with that. That's not a big deal actually.
Okay guys, a quick info. If you want to get certified as a Big Data Hadoop architect, Intellipaat offers a complete course on Big Data Hadoop which covers all the major components and also tools which are used by professionals. Please go through the link mentioned in the description for more details. Now let's get back to the session.
So components of Pig. So actually Pig comes as a package in which you have something called a Pig engine, which runs on top of your Hadoop and converts your code into MapReduce. The language is actually called a Pig Latin. Pig Latin is your language which you are supposed to learn. Now what are the advantages of Pig? It removes the need of users to tune Hadoop, in the sense like if you're writing a custom MapReduce program, then you might have to fine tune the program, but Pig by default optimizes your code. You can turn on and off the optimization, but by default code optimization is turned on by Pig. So that means Pig will create the best optimized MapReduce code for you, and it insulates the users from Hadoop interface, so you don't have to practically learn MapReduce or Hadoop or anything. So if you're supposed to write some 200 lines of Java code, you can write the same thing in 10 lines of Pig Latin. And the same way, if you try to develop a Java-based MapReduce code in 4 hours, the same can be done in 15 minutes approximately in Pig Latin. So it opens the system to non-Java programmers. Now this we have practically seen. So whenever we are writing a Pig code, it's quite how do I say, fast and easy to work with. Now it's a common way for every scripting language, right? So whether you are into Python or say Ruby or to shell scripting, all scripting languages gives you a couple of more advantages. All scripting languages are short and sweet. They have a lot of built-in functions to use. For example, if you look at Python, n number of packages and functions are available, right? Python codes can be very, very small. It's a scripting language, right? So the same way, Pig also acts like a scripting language. But it's not like your SQL, okay? So SQL is more or less like a query. So there, maybe if I want to pull the certain results from a table, I can write a single complex query and run it and get the result. But here, you might have to write it as a script to interact with Pig. So the next is Pig Latin data flow language. So it actually allows you, regular data types. So you can use long, float, char array, int, etc. So that is all possible. Pig also supports complex data types, which I will come in a moment. It is extensible and supports user-defined functions. So that means if you want to add some functionality to Pig, what you can do is that you can write it in something like Java, right, and call it inside Pig. So that is called user-defined function. I will show you an example of UDF or user-defined function. So you can write your own functions in your language, say Java, and package it as a jar file and register that with Pig so that Pig can use that UDF actually. Pig doesn't need metadata. It can work without metadata, without type declarations or anything. But if you provide Pig with metadata, it will work the same way. But Hive is not like that. If I'm working with Hive, my metastore service must be running. I cannot say that, okay, create a table, now don't use any metadata. It doesn't work that way. Either I have to use my own metadata service or something like hcatalog, but metadata is required. For Pig, you don't have to use metadata, but it can use when it is available. It can even share the metadata with other tools like Hive through hcatalog. It operates on files in HDFS. We know that. Provides common operations like join, group, filter, sort. So Pig has a lot of built-in functions. So provides common operators like join, group, filter, sort. So the power of Pig actually comes from these built-in operators. That means whenever you want to perform any operation, so you want to do a join operation, you can call the join operator and it will do the join operation for you, right? So this is actually from where the power of Pig comes into help us, right? What are the usage scenarios? So one thing might be web log processing. I will show you a Pig program which actually takes a web log and process it. Now, Pig is very good at string operations as well as regex, your regular expressions. So this can be extremely helpful in situations like web logs. So imagine you have a web server running and it produces a lot of log files. Now the log files will be kind of unstructured. It doesn't follow a particular pattern as such. You can call it semi-structured, but I would like to put it like unstructured data. And if you want to extract something, you can use Pig. So Pig is very good at trim, substring operations, regular expressions, etc., etc. Data processing for web search platforms, ad hoc queries across large data sets. Even Hive can be used for ad hoc queries across large data set. Rapid prototyping of algorithms for processing large data sets. So who all uses Pig? Yahoo, one of the heaviest users of Hadoop, runs 40% of its jobs in Pig. Twitter is also another well-known user of Pig. So Pig is kind of like one of the most widely used ecosystem tool that is available to us. Pig versus Hive. Where Pig and Hive looks exactly the same, right? Then why do you need, or is there a difference actually between them? Yes, there are differences, right? So if I just have to relate this, the major difference might be starting with this, okay? This is so maybe the first point is that Pig is just a client-side application. So there is no Pig server or something, right? So that means, so Hive can have an optional thrift server, and we have seen a Hive server 1, Hive server 2, etc., and where you will be using what, right? But when you look at Pig, Pig is just a client-side application. So there is no Pig server or something. And why is that so? Because Pig is not a data warehouse, and Hive is a data warehouse where you need to create connections for accessing and storing data. Well, Pig doesn't have to have. And one more thing here is there is no JDBC ODBC connectivity, and here it supports connectivity. So that means either using the Beeline client or from your regular SQL clients, you can always connect to a Hive table. Right, so Hive actually supports JDBC drivers, right? So you can directly connect to Hive and do whatever you want to do. But since Pig doesn't work on tables and doesn't work on storage, there is no JDBC ODBC connectivity. So if Pig has to get some data, the data should be in Hadoop, in a folder or somewhere, and it reads the data, transforms the data, and stores it back into Hadoop. That is what it does. There is no table or something inside Pig, right? And Pig is actually used by developers mostly, and here it is used by analyst folks mostly, right? So I mean, it's up to you, but again, mostly Pig is by developers and Hive used by analysts. And here schema is not mandatory. And here schema is mandatory. You need a schema, right? When you create a Hive table, you need to have some sort of a schema at least, right? And also Pig doesn't have a web server, Here you can have an optional web server, a web interface for your Hive. That is possible. So I think these are the obvious differences actually. There can be much more, but some of the points that you need to consider, right? Where does actually Pig fit in the scenario, right?
Okay guys, a quick info. If you want to get certified as a Big Data Hadoop architect, Intellipaat offers a complete course on Big Data Hadoop which covers all the major components and also tools which are used by professionals. Please go through the link mentioned in the description for more details. Now let's get back to the session.
So let's say you have a Hadoop cluster. I have a MySQL database maybe, and I have a web server here, and I might have an app server here. So what I can do is that maybe I'm collecting data. So maybe I can bring in Scoop here, which can bring my data from MySQL into a Hadoop, right? And from web server, maybe I will pull the log files using Flume or something. So I'm getting all the logs from here. And here also I'm pulling some logs. So you see, I'm trying to collect multiple types of data, mostly structured and semi-structured. I dump all this data in a folder. Okay, so this is my folder in Hadoop. So what am I doing? I'm collecting data from my RDBMS systems, from my web server logs, maybe from my data warehouses, from multiple places. And then I dump them in a folder in Hadoop. Okay, so now the data is there. Now you may ask me, can I send this data to Hive? Yes, you can, but usually what we do is that once it is in this folder, I will run pig, which will read the data from here and transform the data and send it back to Hadoop. So maybe, here is my data, right? And this transformed data will be accessed by Hive for reporting purpose. So pig is actually used as a data factory operator or something which can clean your data. So what happens when you get raw data from the web server logs or from your databases, you may want to clean the data. So the ETL guys can correlate this very well more than that, right? You may have unwanted, information, unwanted marks and traces and cookie related information, robot scrolling information, etc. A lot in the data. So in that case, I may not be in a position to dump this data into Hive because Hive is my final destination where everything gets stored and my reporting tools can directly connect to Hive table. So what I do, I use Pig for transforming my data, cleaning my data. And once Pig cleans the data, I give the structure to the data, and then that data can be stored in a Hive table. So you see, pig is not storing anything. It is reading the data, transforming it the data, and storing it back to Hadoop. Another example is this sensor data, weather data. So if you're collecting data from this weather sensors like temperature, etc., etc., I will again show you an example. What happens is that the weather data usually comes in a very specific string format, which is very difficult to decode. So when I have my whole weather data in a folder, we can easily get the data, use some string operations to get whatever information you are interested, and then that structured data is stored in another folder so that your Hive can access. So pig is used as your cleaning operator or data factory operator to give structure to your data and so that it can be stored in Hive. This is the original concept. Now these days, whatever pig can do, most of the things Hive can also do. Hive can also work as an ETL tool sometimes, but yeah, so pig can be considered as a typical ETL on top of your Hadoop. Where pig and Hive fit in the system, right? Where not to use pig? Well, pig is not really good at pure unstructured data. For example, you have audio, video, images, etc. In such cases, pig might not be the right fit. It may not be able to process. So pig is the best fit use case in terms of structured and semi-structured data. And the next point I wanted to discuss, how come you have a weird name, pig, for this tool? You know, the guys in Apache are really funny, I believe. I mean, there is something called the philosophy of pig. If you want, you can read it. The Apache pig philosophy, wherein Apache explains how they gave the name pig to this tool. So what Apache says is that, you know, first of all, the animal pig can eat anything. Same way, your Apache pig can also eat any type of data, mostly structured, semi-structured, and some sort of unstructured. So that means pig will not say no. Anything you give, it will eat, just like the animal. The second point is that the animal pig is easily domesticated, meaning I can have my pig in the house, pig in my farm. So pig is a creature which can fit into any place. Same way, this Apache pig is also a tool which can very well work with different platforms. And Apache also says pigs will fly. So in the sense, like, you can write scripts on the fly. So that is the pig philosophy. So this is Apache pig's philosophy. See, pig eat anything, right? Pig lives anywhere. Pigs are domestic animals and pigs fly. So check out the pig's philosophy and understands why it is called as pig. A pig actually supports something called complex data types. So it supports your regular data types, and it also supports a complex data type. So what do you mean by complex data type? There are three of them. One is called a tuple. Tuple is very common even outside the world of pig. Tuple is an ordered set of fields. Think about tuple like a row from a table, and tuples are usually represented like this. For example, 19,2, this is a tuple. Then there is something called bag. A bag is a collection of tuples. Well, the definition is not so correct actually, because a bag can contain tuples. A bag can also contain other bags actually. So bag is an unordered collection. So a bag is a complex data type which can contain tuple, or it can even contain other bags. Map is a key value pair. How to start working with pig. So first things first, you have to understand the data that I'm working on. Otherwise, there is no point, right? So first thing you have to understand is the data. Now it is very common in any big data scenarios. You have to understand your data, then only you can start working with the data. So let me show you the data that I'll be working on. So now we have the data to work with. So there are two set of files. Okay, this is called New York Stock Exchange daily data. This has certain columns. For example, the first column is the exchange name, which is New York Stock Exchange. The second column is called a symbol or ticker. This is the stock name that we are monitoring. Then we have the date. So this is the date column. Then you have opening value, closing value, high, low, total trade volume, and another value, right? So basically this is stock data. So every stock will have opening value, closing value, high, low, total volume sold, etc. And this is a real good piece of data set. It's a public data set because you can do a lot of operations on this data. So this is one data set. The second data set is this. It is a similar data set but with only 4 columns. So this has first the exchange name, NYSE, second the symbol or ticker, third the date, and the last column is dividend. So there are 4 columns. So these are the two data sets we will be using initially to understand pig. Now if I go to my desktop, both these data sets are available in my desktop. You can see here NYSE daily and NYSE dividends. So both the data sets are available on my desktop. The first thing you need to understand about pig is that pig can run in 2 modes. One, local mode. 2, MapReduce mode. In this mode, pig will read the data from local file system, transform it, and store it back to local file system. Okay, in this mode, pig will read the data from HDFS file system, transform it, and then what? Store it back to HDFS file system.
Okay guys, a quick info. If you want to get certified as a Big Data Hadoop architect, Intellipaat offers a complete course on Big Data Hadoop which covers all the major components and also tools which are used by professionals. Please go through the link mentioned in the description for more details. Now let's get back to the session.
So, which means you can run pig in two modes. There is local mode and MapReduce mode. Local mode means if you start pig in the local mode, it's going to start it and it will take data from your Linux machine. Basically, it will expect the data from your Linux machine. It will read the data from your Linux machine, right? And it will do whatever transformation you ask it to do and store it back onto Linux machine, meaning it will not touch Hadoop in the local mode. In the MapReduce mode, the same concept, but it reads the data from HDFS, that is Hadoop, transforms it, stores it back into Hadoop. So MapReduce mode is something we use in production. Local mode is for testing. For example, if you want to create a pig script and see how it works, what you can do, you can run pig in the local mode on your laptop. It'll read data from your laptop's hard disk, transform it, store it back on the hard disk. So you'll just experience how pig works using the local mode, right? You can also do this in the MapReduce mode. So the first thing I'm going to show you is local mode. That means how pig can read and transform the data and store it in the local file system, right? So in order to start pig in the local mode, all you need to do is just type pig-x local. Yeah, in local mode, it has nothing to do with Hadoop. And local mode we just use for testing, right? So now I have started the local mode of pig. How do I know? I see this prompt called grunt. So grunt is the pig prompt actually, meaning this is the prompt of pig, right? So here I can type my first pig command. So this is how a pig line will look like to you. A line of code, a line of pig script will look like this to you. So what did I write? First of all, you can see that I have written something called dividends, and there is an equal to symbol, this symbol. So whenever you see this symbol, it means it is a relation. Pig works on something called relation. How do you identify a relation? When you see this equal to symbol, that's a relation. So here I am declaring a relation. I'm saying dividends equals load, this is the file, as exchange symbol date dividend. Now this dividends can be anything. Okay, I just called it as dividends. Okay, you can give any name to that. For example, I can say Raghu equals this. Works. So here what you give doesn't really matter. I mean, it should be something which you remember. By the way, it is not a variable. Pig doesn't have a concept of variable. This is called a relation, not a variable. So now we say Raghu equals load this file. So does that mean there is some data which is getting loaded? No. Load is an operator in pig, or a function you can call it. What load actually does is that it will create a pointer to the file. Meaning, now I am saying that whenever I call Raghu, Raghu means this file. And this file has 4 columns. I'm naming the columns exchange, symbol, date, and dividend. And you see, I'm not giving any schema, meaning the data type. All I'm telling Pig is that, Pig, if I call Raghu, give me this file. And I have 4 columns in the file. These are the headers for 4 columns. That's all I'm doing. Now there are multiple ways to write a relation actually, but remember this, you have to start with a relation to work with Pig. So first step in every Pig script is actually loading the data or pointing to the data, because without the data, how do you work? How do you work without the data? Not possible, right? So now I have created a relation called Raghu, which points to this data, right? And you could have also noticed that when I created the relation, nothing happened. I said Raghu equals to load this. Well, that's fine, right? But did something happen? No. Nothing happened because we call Pig as the lazy operator. Pig, just like the animal pig, is very lazy, right? So to give you an example, let's say you're sitting at home, you with your wife, okay? But imagine you are sitting at home with your wife or with your girlfriend, right? Now your wife comes to you and say that, tomorrow evening, today evening, you have to go out and get something. And she creates a list of things that you have to do. For example, you have to go to the supermarket and buy something. And you have to go to the telephone exchange and pay the bill, maybe. You have to go to the milkman and get the milk. But will you be doing that now? No. Because you are just creating a list of things that you're supposed to do. You are just sitting at your home and your wife says you have to do something, right? So what do? You create a list of things you have to do, right? You will say, okay, milkman, go and get 2 liters of milk. After that, what? Supermarket, go and get groceries. After that, what? Telephone exchange, go and get this. X, you create a list of things to do. But when it is time to do, when it is time to actually go, what you do? You just go out and execute them one by one. That is exactly how Pig will work. So here I'm saying Raghu equals load this data, and I hit enter and nothing happened. Why nothing happened? Because this is like I'm creating a list of to do things. I'm telling Pig that, hey Pig, this is the data called Raghu. So Pig is going to ask me, so what? So what? If this is the data, what should I do? I'm not going to do anything, right? So just for the sake of argument, we'll keep it as dividends. Okay, so you can change it like this. So see, the declarations are completely dynamic, right? So I changed from Raghu to dividends. So now this will be reading it as dividends. So first I declare my relation. Now I don't want you to pay attention to the to the syntax, but I tell a Pig, Pig, group dividends by symbol. So dividends is my previous relation. I want to group that by symbol column and store it in another relation called grouped. So now what happened, there is a second statement which correlates with the first statement. And still is Pig doing anything? No, it is not doing anything. It is very lazy. It sits idle. Okay. Then I say for each group, that is a previous relation, generate the group number, calculate the average of dividend, store it in a relation called AVG. So I have typed 3 commands here. These are the 3. Or in Pig's terms, 3 relations. And nothing has happened. Why nothing has happened? Each line is red. And Pig will look at it and see whether it has to do something. Yes, it has to do something, but are you asking for the output? No. Unless you ask for the output, Pig will not do anything. Pig will sit lazy. So in the first line, I will say, okay, load the data. Second line, I will say, okay, group it by the symbol column. In the third line, I will say, calculate the average of every dividend. Fine. But finally, what should I see? I should see the average, like a print statement in Java, right? So finally you say system.out.println. That is where you see the output, right? So I have not done a print statement for pig. How do I do a print statement for pig? I will say dump avg. So dump is a keyword in pig, which basically says execute this relation. Dump means you're asking pig to do it or print it or show me the output. Now when you say dump avg, it's going to read this line. It says avg is collected to grouped. So it'll go to this grouped. This is related to dividends. So it'll go to dividends. So it starts executing line by line and show you the result. If I hit enter, a MapReduce job will be fired. Pig executes it line by line and will show me the average. And you do have the average here. All the entire stock average is written. This is how pig works. I mean, I don't want you to understand the syntax right now, but just the feel of pig actually. You first create a relation called dividends. Then on that relation you do grouping. On the grouping you calculate average. Then you will say dump average. This is one way of doing that, right? So, but there is a problem with this. The problem is that you're typing the commands line by line. You're typing the commands line by line. And the last line says dump avg. Dump is a keyword which we use to show the result on the screen, and avg is your previous relation, right? So if you don't want to do this, you can just quit from here. You can write it as a script. So what I can do, I can create a new file. I will call this file as testing.pig. So what is the name of the file? Testing.pig. So this is how you create a pig script. You can give it any name, .pig. And inside this file, I can just write my commands. So let me just copy paste them. So I just created a file called testing.pig. And if I open the file, it has the same 4 statements we had, but written like this, right? Now what I can do, I can say pig-x local. This means I'm running pig in the local mode, meaning the file will be read from my desktop. My desktop already has the file, and then run the script called testing.pig. If I hit enter, it should execute that. Same thing, and you get your prompt back, right? So either you can work interactively with pig by launching the shell, where you have to type in line by line the commands, or if you are an expert, if you're very good at pig, you just put all the commands that has to run in a .pig file and run it. Both ways it is fine, right? So what did we learn? We learned that pig can work in the local mode, right? That means it is reading the data from your local machine and storing it also. Now another thing, if I open this thing, so one problem with this script is that the script will read the data, find the average and show me the result, but it is not storing the result anywhere. If you want to store the result, instead of dump, you can say store average into, then you give a folder name, say April 8. So what am I saying? I'm saying execute the 3 lines and then store avg into a folder called April 8. Now if I run the script, it should run the same way, but should store the result in a folder on my machine. Done, right? So now if I do an ls, there is a new directory called April 8. And if I go to April 8, there is a file called part R. If I open the part R file, here is the result. So either you can ask Pig to show the result on the screen, or you can ask Pig to save the result in a file. Both ways it will work. April 8 will be the folder name it will be creating. Inside the folder, the part R file will be there. Look at here. See, I'm inside the April 8 folder, right? There is also the map reduce mode of Pig, right? So in map reduce mode of Pig, what Pig will do, it will read the data from HDFS, do the transformation, store the data back. In order to demonstrate that, I will use the same example, but my data will be in Hadoop. So let me show you that the same data is available in Hadoop first. So this is my Hadoop, right, Hue, and you see this NYSE daily and NYSE dividends are already available in Hadoop, right? So all I need to do, if I want to run Pig in the map reduce mode, just type Pig and hit enter. Remember previously you used to type pig-x local. Now you have to say just Pig, and you see the same grunt prompt. But there will be a difference. For example, the same command I can say, I will write it again. I have to say load /user /cloudera / so I have to give the Hadoop path here. I have to give the Hadoop path here, right? Now if I want to store, I can say store dividend into, I can say /user /cloudera / a folder name April 8. So this will start the MapReduce job. It's going to store the file into Hadoop to a folder. So you can see that it is creating the jar file and running the MapReduce job, etc., etc. So the MapReduce launcher is done here. You can see it is 0% complete. So it's a proper MapReduce job because you are running in the MapReduce mode. Done. So you see the result, right? And if you go to my Hue, if I go to my Hue, just go back to the same directory again, it should have created a folder called April 8. Here is April 8, and here is the result file. So my point is that running Pig, the commands and all are same in local mode and MapReduce mode, right? If you want to run Pig, it's same, right, in local mode or MapReduce mode, right? Only difference is that, you know, in local mode, you have to give the input path from your Linux and output path in Linux. In MapReduce mode, give the input path in Hadoop, output path in Hadoop. That is the only difference, right? So now we can look at the schema. Look at what I'm doing. If you carefully observe, you will understand what is happening. So first, let me start Pig in the interactive mode, the local mode. I'm going to start Pig in the local mode. That means I have the file in my desktop. I want to read it and do something, right? So I started in the local mode, and what I'm going to do is two things. So first thing is this. I'm going to say dividends equals load the data as exchange char array, symbol char array, date char array, dividend float. So this is explicit data type declaration, meaning this is usually how you work with Pig, because you will have the data and you will know the columns, and you will know what data type you want. So what you do is that you will tell pig, hey pig, load this data called NYSE dividends, which has 4 columns, and these are the data types of all 4 columns. If you do this, pig will stick with whatever data type you have provided, just like any other programming language. So here I'm saying that these are the data types I want. And how do you know the data type of a relation? You say describe dividends. So when you say describe dividends, it will say that dividends has 4 columns, and these are the columns. Now let me do now dividends. Describe here. What I did, I loaded the data saying explicit data type. I said these are the columns, these are the data types. Then I said describe dividends, which will show me the data type for dividends, and it says these are the what data types that we have. Then I said dividends equals load NYSE underscore dividends. Let me just, or you can say daily. Okay, so let's take another example. Or you can say this, and you can say describe daily. So I'm just saying that load the file. I'm not giving any schema. So then if I say a describe, what it is going to tell me? So pig will say schema for daily unknown, because you are not mentioning any schema, right? So now the question is, if I'm just loading the file like this without describing the schema, can I perform some operation on the file? Yes, you can do that. That is the real advantage of pig. And I think no other tools have this advantage. Very less tools have this advantage. I'm going to show you that. So now what I did, I just loaded the file called New York Stock Exchange Daily. It has like 8 columns. I did not even give the column names or data types or anything. And then I just said describe daily, and pig tells me that schema is unknown. But you can transform the data. So I loaded the data, and then I'm saying for each daily. So what is daily? Daily is this data, right? Generate $7 by 1000. So $7 is 8th column. So we represent column with numbers, $0, $1, $2. So I am asking pig to divide every number in the 8th column by 1000. Again, I am asking pig to multiply every element in the 4th column by 100.0. Then I am asking pig to extract the first character from the first column. I am also asking pig to subtract the 7th and 4th column elements in every row. Now leave the syntax. So it is using an operator called for each generate, but basically what I'm asking pig is that, hey pig, look at this thing called daily, right? And it has 8 columns. You have not given any column name, that's fine, but it has 8 columns, right? So obviously when you load the data, if the data is tab separated, pig can read. So pig expects the data which is tab separated. So every column should be separated by tab. If your data is not tab separated, you can give an argument like comma or whatever you have. But by default, my data is tab separated. So when I say load NYSE daily, pig will automatically identify every column. It's going to name every column like $0, $1, $2, $3. Then I'm saying for $7 by 1000, that means I want every element in the 8th column to be divided by 1000. Every element in the 4th column to be multiplied by 100.0. And substring operation means from $0, that is the first column, I want a substring 0 to 1, first character. And I also want for every row subtract $6 minus $3. That means 7th column minus 4th column. Now what I am trying to tell you is that you are asking Pig to divide every element in the 8th column by 1000. So when you ask somebody to divide something by 1000, that means that number should be an integer. So Pig will automatically cast it as integer, the 7th column. Again, for the 4th column, you are asking it to multiply by 100.0. So when you say 100.0, multiply something by 100.0, Pig will assume and cast the column as double, data type double. And when you say substring, it will automatically understand that you want to extract characters. So it's gonna understand that this is char array, right? But when you say minus $6 minus $3, there can be a confusion because you are asking Pig to do a subtract operation. Now, the subtract operation can be between integers, can be double, can be floating point, right? So for precision, Pig will assume both are floating point and will do the subtraction. Now, if I do a dump of this calcs, you can see it will show the result. See, even without giving any schema, it is able to understand your schema. So the first column is integer because you're asking to divide by 1000. The second column is casted as double. The third is char array. The fourth is again a floating point, right? So I will show you this calc relation once more. Now look at the result, you will understand. So this is what will happen if you do not mention the schema. Ideally, you should mention the schema. So that is another thing. Ideally, for Pig to work on, you should mention the schema. I mean, that is what we do. But in some cases where you don't have the schema as well, you can quickly load the data and transform. For example, imagine you're getting a text file with some 10 columns. All are whole numbers, integer. You can just load it and do all the operations. You don't have to declare any data type. Because, you know, when you say, okay, divide by 1000, it'll understand it is integer by looking at by what number you are dividing and cast it as integer. Let us look at the operators or the syntax in writing. Operators in detail, right? Now, what is the load operator? The load operator will, like I said, create a relation which will point to your data. So if you look at my data that I was using, it is this NYSE underscore dividends or NYSE. So if I open this data, you see this data is tab separated. The separator is tab. And by default, Pig will understand your data if you're using the tab separator. But what if your data is not having the tab separator? What if your data has comma, right? So what you can do is, if you look at this data, this is the Olympic data set, and this is comma separated data. This is the comma separated data. Now, what can I do with this data if I want to load it? Very simple. All you need to do is, in Pig, you say A equals load, say Olympic using Pig storage. Now I'm saying load Olympic, this is my file, using pig storage, comma. So you have to say this pig storage if you're having another type of data. Now I can simply, so this is the load operator. So if I say load Olympic only, it will expect the data to have tab separated values. If I say load Olympic using pig storage, comma, that means it expects the data with comma. So this is very good if you have CSV files or comma separated values, etc. This is how you can load the data. And just to see whether the data is loaded, do we have a schema? No, there is no schema because we have not mentioned. You can say what? Dump A. It should dump the data. And you can see the data. So you see the data is perfectly loaded. So you have to see this using when you're using the load operator. And we also know this store operator, right? If you want to store the result, so this is the load data, then I can say store A into Hadoop folder name, whatever. So you have to create a folder here and it will store. Dump will show you the result on the screen and store will store the data in a folder. So either you can use the load store operator or the dump operator. Dump operator will show on the screen, which is not so good. If you're having like 1 million lines, it's going to throw all the 1 million line on your screen. Rather you say store, it's going to store someplace. In Hadoop, you can give any folder name which you have access to. Relational operators. Okay, we have something called relational operators, right? So now let me show you a couple of examples for this. So I'm going to load another one. I'm going to create a relation here. I'm going to say load NYSE daily as, I'm just giving the column names here. Exchange, symbol, date, open, high, low, close, volume, ADJ, close, right? So I'm going to load that. Now, the first operator you have to be familiar in Pig is the for each operator. So how your for each operator works is that it is going to take every row and apply an operation you are mentioning. So here I'm saying close minus open. So there is a column called close, another column called open, right? So it's kind of like a SQL loop, right? So it's going to apply something like a SQL loop. It's going to go iterate through every record and subtract. What if I want to see whether this is working? What should I do? So I have to dump the operator called gain. So I will say relation called dump gain. And that's it. I can also do much more things. Okay. So now what I did this, right? I can also say C equals prices. I can say for each prices generate $0, $1. And now let me do a dump of C. Did you see what I did just now? I said for each prices generate $0, $1. Right? That means you are just extracting 2 columns. And when I did a dump, what did I get? Exactly 2 columns. So how easy it is to filter, right? I just want 2 columns or 3 columns, You don't have to even cast it. You don't have to say the data type. You just say load for each. That's it. You get. And store it as a separate file. That's it. So this is data transformation. So that is what I'm saying. It is very easy to transform your data. Is this relations case sensitive? That means, okay, A equals load is not same as A equals load Here I'm saying A equals load abc.txt. And I'm also saying capital A equal load. So small a and capital A are different. So relation names are case sensitive. But I can say either this or this. So the operators like load or for each, either you can use small letters or capital letters, but the relation names are very specific. Now you can also do this. For each operator can be used for mentioning a range. So again, I'm loading the same data, prices, right? And I can do these things. You can say for each prices generate dot open. That means it produces exchange symbol date open, all the columns till open. Or you can say open dot close. That will be open, high, low, close. Or you can say volume dot. That means volume and adj underscore close. So you can mention a range of columns like this. So I say I created a relation called divs. Okay, and I'm loading the same one. And I can say, okay, so here I'm creating a relation, right? And how many columns we have in this relation? Well, it's not called columns in what you say pig. It's called a record. Sorry, it's called a field actually, not a record. How many fields we have in the divs relation? 4. Exchange, symbol, date, and dividends. So we have 4 fields, right? And look at what I'm doing. I'm saying here a new relation in underscore sense. For each divs, generate dividends into 100 as dividend, comma, dividends into 100.0. So this is a bit confusing the way I write it, right? So I'm saying for each divs, that is my previous relation, generate, I want to multiply this field called dividends into 100 as dividend. So what do you mean by here as dividend? I have written dividends into 100.0 as dividend, again dividends into 100.0. It is the field name. See, what I'm telling to pig is, multiply every element in dividends column or dividends, what you say, field, right? And store it as something called dividend. So I'm creating a new column or a new field called dividend. But on the second relation, what I'm doing, I'm saying multiply every element in dividends, but I'm not asking to store it as a new column. So what will automatically happen? A dollar will be created. So if I do describe, see, it has a column called dividend, which is double. The second column is just double. There is no column name, and you will be able to access it by $1. Did you understand that? That means whenever you're performing any operation, you have to say as some column name, right? Otherwise, it will create a column with a dollar notation. Okay, let's go to filter. So in filter operator, I will just load the data first. So it says load dividends as exchange carry, symbol carry, date carry, and dividends float. Okay, and I can say filter divs by dividends greater than, I don't know what's the data we have. See, what did I do? First, I loaded the data. So data is loaded like this. NYSE dividends as exchange, symbol, date, and dividend. Then I can say filter divs. Divs is my previous relation by dividends column greater than 0.14. I want all the rows where, so you can say some column greater than some value, less than some value, equal to some value. And then I did a dump of D. It will dump D and show me all the records where this column is greater than 0.14. So filter operator will take a condition. Filter will say that filter the relation where the column value can be greater than, less than, something, something. Now that will work for integer, floating number, etc. If you are having characters, for example, in this example, first two columns are characters, right? Third is date, leave it. But first two are strings, right? So what I can also do is that I can say what? Filter divs by symbol, which is my column name, matches cm dot star. So that is like matching with an expression. So I want all the records where in the symbol column it starts with cm. If I do a dump, see all CMO, CMA, CMS, CMI, CMK. All you need to do is that filter a column, either a regular expression or you can say greater than, less than something. That is the filter operator, right? So that's the filter operator. Now you also have a very important operator called grouping operator. Okay, so this grouping operator is very, very, very important in case of pig. Just see, there are so many operators actually. Let's look at grouping first. Anyway, so first let me load the data. Now you can also load the data like this. Look at here. I'm saying, load NYSE daily as exchange and stock, meaning I'm just using only two columns. I'm just using only two columns. So it will load only two columns, right? I will say group daily by stock. So grouping is a very common operation. We see grouping in SQL, grouping in many places, but grouping works in a very different way in your pig. So all I'm seeing here is that I want to group the previous relation, which is my data actually, by stock name. So you will expect all the stock names will come together. Yes, it will come together, but in a very specific format. If I do a dump of grpd, okay, so this is the grouping result. Or let me see whether I can get any other data set. So I can say A equals load Olympic, okay, using pig storage, comma. This is the Olympic data set. And since I did not mention any schema, it's going to load with default schema. Okay. Now I want to access, let's say 0, 1, 2. So I can say B equals group A by 2. So what I'm saying, Group A by $2. So what is $2? $2 is the country. I want to group the data based on country. When I say dump B, this is what you will be getting, and this is probably what I want to show you as well. Yeah, so look at this. You have the country name. So let's see a country where there are very less athletes actually. So it's easy for us to identify, right? Look at here. This is one record of grouping operation. This is one record. So here it will have two parts. One is the grouping key, which is the country. So I'm looking at the country called Dominican Republic. Second part is all the records which belong to Dominican Republic. Look at here. So there is one guy who is in Dominican Republic, and there is another guy, there is another guy, there is another guy. So this is how the grouping result will happen. So my point is, when you do grouping operation, the result is like a key value pair. The key will be your grouping key, in this case the country, in my record Dominican Republic. The value will be a bag which contains all the records matching with Dominican Republic. Same way you have Trinidad and Tobago. If you look at here, another country, right? And these are all the values of Trinidad and Tobago. So look at the first element, Trinidad and Tobago. That is the grouping key. Then in a bag, you have all the athletes who are in Trinidad and Tobago. So this is one record, one athlete here, right, from Trinidad, then another athlete here, etc., etc. So what I can then do is, for each B, generate group. I can say something like this, and count, let's say A equals load Olympics. Then I said, where is B? B equals to group this. Then I can say C equals for each B, generate group, comma. Then here we are basically what we are doing is actually counting the data. Count. Then I can say dump C. So this statement means we are just loading the data. Fine. Then what did we did? I said group A, which is my original data, by $2. $2 is what? My country column. Then in C, for each B, generate the group name. So I want the country name and count A. So what will be A? A will be my original data, right? A is where I'm loading every record. So it's going to count. So basically, this is going to give me a count of every country. See, New Zealand, there are 51 records. North Korea, there are 21 people. So grouping is very useful in doing things like this. Grouping is very useful in, and for NYSE, you can do the same thing. You can say load NYSE daily as exchange and stock. That means I'm loading exchange and stock. Group the relation called daily by stock. Then I can say for each group, generate, so previous relation group, and then count the daily. So it will count how many are there. So this is how we do the grouping operator. You can also say order by. I say daily equals to load this, right? And I can say order daily by date. So what this will do, it will look at the date column and order that. By default, it will be in the ascending order. You can say descending as well, right? So so by default it will be in the ascending order. Okay. You can also do multi-column ordering. I can say order daily by date, comma, symbol. If you want, you can do that also. Okay. And you can say order daily by close descending, comma, open. So this close field will be descending, other will be ascending. Yeah, so here is join operator. So if you want to do join, you can simply load the data and you say divs load as exchange. You can say join daily by simple date, divs by simple date. You can do single column join or multi-column join. Let me just show you this. So I will load the data called daily first, and then I will load the data called divs, and then I can do a join. So this will be normal join, right? You can also do left outer, right outer, full outer, whatever type of join you want. So here I'm saying join daily by symbol comma date, divs by symbol comma date. If I dump J and D, it should have the multi-column join result. See? So this is the join operator. You can also say limits. Okay, so I can say load the data. So here I'm saying load the data. I'm not giving any schema. I can say limit. I can say limit divs 10. Okay, now if I dump first 10, what's going to happen? It's going to show me only 10. So what did I do? Limit divs 10. So the limit operator will limit how many records will be shown. How do I say? Random selection, you cannot say which to limit. So the limit operator actually limits your data, right? What a word count program. Now the first thing I'm going to do is that I'm going to run the word count program, right? And just ensure that it can actually do the word count. We will look at the script later. First, we will run the script and see whether we are getting the result. So I have the script. This is the script actually, which will do the word count for us. And I will explain the script later. As of now, we just have to run the word count program and see what is going to happen. This is the script which has this word count.pig, and all I need to give is the file name, and the file which will be analyzed is this file. This is the file which will be analyzed. Mary had a little lamb, its fleece was white as snow, and everywhere that Mary went, lamb was sure to go. This is a nursery rhyme, right? So we will do the word count on Mary had a little lamb. So this is the sample data that I have for analysis. So in my script, I have to give this data. So what I'm going to do, I'm going to open my script and I'm going to say that this is what I want to load. And then I'm going to run this first. I'm going to say pig-x local word count.pig. So this is how you run the script. So I'm just going to say that, hey, pig, run this for me, word count.pig, and just show me what it is there, right? I'm just going to hit enter and see whether we are getting the expected result. And we are able to do the word count very well with the script. So it is just a 4-line script that we have, and it actually does the word count. Now compare this with your Java program, the MapReduce program, which was doing word count. It was very complicated to write, right? So this is quite easy to do it. So now, all right. So now let's see what is going to happen. I'm going to just explain the script. Rather than explaining the script, what I will do is that I will run it line by line. If I just run the script, you will not understand anything. So what I'm going to do, I'm going to run it line by line. So to do that, I'm just going to start Let's analyze the script. This is the first line in my script, and I don't think it needs any explanation. All I am doing is that I'm loading the data as a single column, a single field. So I'm calling this entire, 4 lines of data as a single column or a single field. The name of my column is line. The name of my column is line. Now I'm not mentioning any data type or anything because since it is a word count, I really don't know what will be the data that I'm getting in. I don't know. So I'll just say that load this data as line. So line is my column name. What is line here? It's a column name basically, right? Then what I do is I do this. So I will create another relation called words. For each A, that means for every line in my data, generate tokenize the line. So what is line here? Line is the column. So line means, the column which represents your data. Tokenize is a function or an operator in Pig which will extract every word. So basically what tokenize will do, it will pick every word. Flatten means it will create a row for every word. So basically, when you say for each A generate flatten tokenized line, what it is going to do is that it's going to read every line, extract every word, and for every word, it's going to form a row. So basically, it will arrange all the individual words in a single column. As word means that will be my column header. So think about them like column header. Here line is your column header for your original data, and this is the column header for the transformed data. Now if I do a dump of words, so I'm dumping this relation, okay? So if I'm dumping this, this is what you get. So what that flat tokenized flatten will do, it's gonna pick every word and arrange them in a column like this. So now I have all the words that I want to count, but I know that Mary is repeating here. So here is Mary in the first row, and again Mary is here. So Mary is repeating 2 times. So if I want to count Mary, I should group them. So the next step will be grouping my data. So I will say that GRPD group words by word. Words is my relation, word is the column name. Okay, now don't get confused. Words is my relation, word is the column name or column header. So I'm saying that group the relation called words by the column word. Now the column word has all the data. What data? This data. So this is the column which contain word actually. So remember the grouping operator in Pig. So I know that this is my data, I mean the previous relation, and I know that I'm doing grouping. I know that I'm doing grouping, but being a Pig developer, what you should know is how the output of grouping will look like. So to do that, I will do a dump of this relation called grpd. I'll take a dump of this, and this is how it looks like. Look at an element called Mary. Now this element or this record called Mary has 2 columns. First column is the grouping key, which is Mary. Second column is a bag which contains a tuple, I mean not a tuple, the repetitions of Mary. Right? So first is the grouping key. Second is the actual number of repetitions of Mary. Same with lamp and snow, sure, they just repeat only once, right? But this is what you need to understand. Now what I need to do is I have to say for each GRPD, So GRPD is my previous relation. For each GRPD, generate group. Generate group. So what is group here? Group will be this first column. And count words. What is words? Words will be this column. So if I apply this, what is going to happen is that it will generate group called Mary and then count 1, 2. 2 times Mary is repeating. Now remember that words is your original relation, right? So this is words, the column called words, remember, so that is where the column which contains all this, data, right? And I grouped it. Then I'm saying that count these words. So basically these words, this Mary is actually part of words, right? So I just want to count this 1, 2, right? And this is group. So if you look at here, see, group words by word, right? For each generate group. So generate group means it will generate the grouping key and count it. Right now, if you do a dump of CNTD, you have the final result, right? So always remember the result of a grouping operation has two parts. One part is the grouping key. The second part is the elements that are repeating. So in this case, Mary will become the grouping key and Mary comma Mary will be the result. Also, all you need to do is that, for each generate the group and then count that relation. So it will count how many times it is happened. So this is how you write a word count program in Pig, weather data analysis using Pig. So basically this is string operations actually what we are going to do. Now let me first show you the data, then I'm going to explain what we'll be doing. So this is the data which we are going to analyze. And it doesn't look nice. The data doesn't look nice. Why it doesn't look nice is because it is the weather data. So what do you mean by weather data? So these are the type of data that we get from sensors and all. So this data basically has temperature readings and lot more than that, but we are actually interested in temperature readings, right? Now, if you look at the data, you may think it doesn't have a structure, but it does have a structure, right? But you cannot really put it into a column format and all as of now because the way it is given is kind of like very funny, right? So what we are going to do from this data is this is kind of like unstructured data, semi to unstructured data. We are going to use Pig to extract the information that we want. So I just started Pig in the local mode. And if I look at the commands that I'm doing, okay, so first thing that I'm doing is that, so what's the file name that we have? Let me just check. It is weatherpig.txt. So first thing I'm going to do is that I'm going to load the data. I'm going to say A equals load this data using text loader as data and char array. So basically I'm going to declare this as char array because I want to perform the substring operation. I want to perform the substring operation. So I'm going to declare this as char array for the time being. All right. So then what I'm going to do, I'm going to say for each A generate trim. So trim is an operator which you can use in Pig basically to trim, and then you can say substring from this column called data 6 to 14, 38 to 45, 46 to 53. So what does this mean? So basically I want to extract character position 6 to 14. So where is that? 6 to 14. 0, 1, 2, 3, 4, 5, 6. 6 to 14 will be this data. So since I'm loading it as char array, what it will do is that it's gonna get this, right? And this is going to be the date column. So this is the date actually. You can see it is 2013 January 1. Same way I'm gonna extract from 38 to 45, which is minimum temperature, 46 to 53, which is maximum temperature. Now you might naturally ask me, how do you know that this is the data? You have to ask the guy who is giving you the data to understand the data structure, right? So, once I extract that, basically, I can actually dump off this and see how it looked like. Dump AF, and this is how my data looks like now. So now the data is extracted into the date. So date is there, comma, minimum temperature, comma, maximum temperature. So I have this format now for my data, but this is not I want to do. So my use case is different. So what I'm going to do now, I'm going to store this data. So I will say store the data into a folder, right? So how do I know whether a folder is created? So if I do an ls, there is a new folder called data9, right? If I go to this folder called data9, do an ls, there is a part m file. If I cat into this part m file, I have the data. So basically I stored the data in a folder. Okay, so once your data is stored in a folder, what you can do is you can give structure to your data. I can say that possibly this will be data9. I can say load this data which we just extracted using pick storage comma, because the data is comma separated, as date, minimum, maximum. Now you are creating schema for this data and loading it into the relation called S. So now this relation called S will have 3 columns which you have extracted from the raw data, and these 3 columns are even having specific data types like char array, double, right? So now I have the date, the maximum temperature, and the minimum temperature. And what I can do, very simple. If I want to find the hot days, what I can do, I can say x equals filter s by max greater than 25. So I'm saying that filter the previous relation, okay, by the column called max greater than 25. So I'm assuming that any day which is having a temperature of more than 25 is a hot day. So now if I dump x, I will get all my hot days. So look at this. On the last column, all are more than 25, the max temperature. You can also say min less than 0. You can find the cold days actually. So I can say x equals filter s. S is my previous relation by min column less than 0. Now if I do a dump of x, I should be able to see. So you see the second column in this result, right? All are less than 0, right? So basically that is the condition I have given, right? You can also do a lot of other things. Now these are more towards the statistic stuff, right? This is more towards the statistic stuff. So basically if you want to find out the hottest day, what you do is that you do a group S all. So I will say, so normally you say group S by the date column, by the minimum column, by the maximum column. But here I'm saying group S all. This is a very special grouping I'm doing. See here. So this is what I want to show you. I'm saying group S all. So normally you say group by. So now if I take a dump of H1, the result will be very interesting. So this is the result. See, group S by all actually means it will create only one result. The key here will be all. Can you see this? The key is going to be all. The values are the entire data that you have. So when you say group as all, so you are asking to group by everything, which is kind of like impossible. So what pig will do, it will create a key value combination in which the grouping key will be all. All means everything. And the value part will be every element in your relation. See, so this is what happens. And then what I'm doing, I'm saying, for each h1, so that is my previous relation. For each h1, generate max s dot max as maximum. So I'm declaring a new column here. So that is why I'm saying as maximum. I'm using the max function. Okay, s dot max. That means in this, I'm going to find the maximum. So then if I do a dump of this relation, I should see the max value. So that is 34.1. This is the max value that I'm getting. Now, so I'm finding the hottest day. So then all I need to do is that I have to say filter S. S is my original relation by max, that is a column, equals I dot maximum. So I dot maximum will be this. So basically finding the maximum and filtering the data. I want the record where this 34.1 occurs. So that is basically if I do. So if I do a dump of X, this will show me the hottest day. This is the hottest day. 2013, 12th June, maybe. It's a bit complicated to understand, but I guess you got the grip of it. So first I will group S by everything. Then I'll say for each H1 generate maximum, S dot max as maximum. So this will give me the max value. Then I will say filter the S by max equals I dot maximum. So it will show me only that. Same way you can find the coldest day as well. So same way you can find the coldest day as well. Okay, you can just say max of the column and then do the filtering also. Here I wanted to show you this group as all, so that is why I used it this way. Okay, so you can also say that instead of doing this, you can say for each S, generate max of the max column and filter that by I dot maximum. That will also work. S dot max actually means S dot max means in the relation S, the max column. In the relation S, the max column. So the only thing here we are doing is group S all. This will create a result wherein the grouping key will be all and the values will be everything in your S. So S is your basic data, right? And then I'm saying for each H1 generate the max. Max is my operator. S dot max. S dot max is my column as maximum, right? Then I'm saying that filter S by max equals I dot maximum, right? So this is the way I have written. I suggest you to try a little bit different also and see how it gives you the result.
Okay guys, a quick info. If you want to get certified as a Big Data Hadoop architect, Intellipaat offers a complete course on Big Data Hadoop which covers all the major components and also tools which are used by professionals. Please go through the link mentioned in the description for more details. So this brings us to the end of the session. If you have any queries, please comment below in the comment section so that we can get back to you as soon as possible. And also, don't forget to subscribe the channel so that you will never miss any upcoming video. And thank you for watching.